My name is Mrs. Cost. I am here today representing the company KS Analysis, and we are also co-represented by the company European Group in Germany, which serves as our official dealer and distribution partner. We're starting the measurement now. The first step is to position the device on the first measuring point. The distance between measuring points is 2 meters. We go measuring point by measuring point, 2 meters apart. The measurement is there. The interpolate box really needs to be checked. Let me think about it. Here you can set how many measuring points you want to have in a row. You have the option of 5 measuring points in a row, 10 measuring points, 15, 20, or 25. It depends on how large the area is that you want to measure. Here you can also adjust settings if you want to improve the result. You have to try it out. You can record with 1 volt, with 0.5 volts, or with 0.2 volts. Today we're recording with 0.2 volts because we have the best experience in this area with this 0.2 volt setting. Looking down here at the display, you can clearly see that during the measurement, the first row, if you decide to do 3 rows, you can see that it is showing one of the 3 total rows available. You can also switch back and forth, which will show at the end of the video. It's the same with the points. Once you have finished the measurement, you must be sure to carefully adjust this depth slider, where you can then clearly see the results right here, how the depth is. Furthermore, here you can also adjust the color scale settings as needed. To choose which color you want to use during the measurement. It is very important that you make sure this depth slider is properly adjusted before you click to export the CSV and save the file, especially when you are exporting that CSV data for use in your 3D modeling software application. The CSV file can then be loaded into the 3D software. Before that, you absolutely have to adjust the slider. If you don't adjust this slider and the slider is set to 0, then the following happens. You won't have any data in the 3D software, and no measurements will be displayed at all. Now I would say, let's start the measurement. Every 2 meters, we have to set down the device and set a measurement point in the software. To record the measurement points, we simply press the button, the blue light will illuminate, and the recording will stop. Clicked in the software. The whole thing has to happen in the short time while the blue light is on. The measurement is now complete, and we are now going to save the recorded data from the measurement. Click File and Save, and we're saving it on the desktop. And we'll just call this measurement the final value, Alpha and Charlie. And then we just click on Save. Good. Let's check on the desktop if the measurement is there. Do you see that? That should be it, AC. Next, we'll go back to the raw interface and we will use the specialized 3D software for detailed data analysis, where we'll adjust the settings for the depth and the overall depth scale to ensure everything is correct. When you move this slider, you can see how you change the depth here. And the depth of the scan, exactly how far down you would like to look in the measurement, can be adjusted and set right here. We've just now set it. We're at about 20 meters. We'll take a USB stick. Ms. Cost, can we get an explanation here of what these results are called? This is the display in the 2D software. This 2-dimensional software is used for accurately recording and storing the measurement data. The analysis is performed in the 3D software. This Stone Age software is primarily used for recording the measurement data. You can take a moment to analyze it and see exactly what we have present here in the ground. Here you can see, as a clear example, these could be partition walls in a bunker, but they could also be cables or pipes. We can analyze that better in the 3D software than in the 2D software. This software is only intended for preliminary analysis. Now, data carrier. The data carrier, where we now save the measurement again as export CSV, save export CSV, which is required for the 3D software. And now we save. To check, let's just look at the stick again to confirm if the recorded measurement was saved. There it is, a C.
That's it.
At this point, okay. Now we can exit out of the software application, and the 2D program has been successfully completed. The measuring stick is now carefully inserted into the side of the laptop. You can also see measurement ACCSV here. Yes, we're starting the 3D program. All right, everything looks good. The measurement is currently loading for you right now. We have to go to the stick. And here is the measurement, a CSV extension. It's loaded in. Now we're going to begin processing all of the data within the specialized three-dimensional software. Initialization. And we can now take the following steps to transform the measurement into something visible as an image. These right here are the necessary functions that you have to load in so that it is possible to successfully show the measurement. We also have the option here to change the colors. With IsoSurface currently activated, we can navigate over to the color scale. And you can choose the color on your own, exactly how you want it. And here you can see very clearly this is the actual measurement. This is a bunker. And if the data collection process had been continued, if more measurement series had been systematically incorporated here, then the bunker would have been fully and clearly visualized in the final measurement image. This function can also be used for metallic materials if pipes are installed. You can make them a bit more visible with this. There are many possibilities in the software to display everything. And here you can see it's shown as metallic. What we just saw in the 2D software is also correctly seen here in the 3D software. And these are the structural pillars I was just discussing earlier in the 2D software. You can see them very clearly displayed right here. This is the cavity. The entire area is filled with intricate structures that have been embedded directly into the clay soil. You can also manually use the slider to precisely fine-tune all of your settings. Just use the sliders to make everything visible. Let me just say it once more. This is the depth scale, which you can also display correctly, by the way. The green axis, those are the rows that we have made, and the red axis are the measuring points that have been made. And if you had continued to measure additional rows of data in a steady manner, you would see that the long green directional arrow would be filled in much further toward the far right-hand side of the screen to represent the data. Now we'll save the whole thing. We can just do that on the stick again. The measurement is called AC, and just click on Save. And the measurement is on the stick.